if our angle is not a quadrantal angle or isn't on the unit circle, we can create something called a reference triangle to determine the trig ratios. And this is probably one of the most important things that I can explain to you in the first half of this chapter. It's that a reference triangle is always based off of the x-axis. In other words, we will always be using the x-axis as our points of reference. So if I were looking at that from the perspective of the coordinate plane, there's only 4 places that I can draw a reference triangle. Right there in the first quadrant where the x-axis is one of the sides. Right there in the second quadrant where the x-axis is one of the sides. Down here in the third quadrant, which once again that x-axis is one of the sides. And then finally in the fourth quadrant. And when you look at that picture of your possible reference triangles, you have this bow tie look. So we're never going to use all 4 of them at the same time. You're only going to have one of these 4 triangles of the bow tie. What we don't want to see happen is we don't want to see our triangles based off of the y-axis as being one of the sides. Right here you can see the x-axis isn't one of the sides, but we use the y-axis. That would be an issue. So this right here is bad. You do not want to use the y-axis as one of your sides of your reference triangle. It's always going to be the x-axis. So this example, 5 pi over 4, is on the unit circle, but let's go through the thought process as if it weren't on the unit circle using this reference triangle idea. So we want to find the 6 trig functions given the angle 5 pi over 4. And I know it's 5 pi over 4 because every single one of those is 5 pi over 4. So there's my circle, and I am going to draw a reference triangle. The way I do that is I ask myself, which quadrant is 5 pi over 4 in? And 5 pi over 4, if I'm not comfortable with the radians yet, is 225 degrees. And if I know a straight line is 180, if I know the angle down is 270, 225 is between 180 and 270. So we'll draw our reference triangle in the third quadrant. And there's this piece of the bow tie that I mentioned. Only going to use one angle at a time. And since I said 5 pi over 4 is the same thing as 225 degrees, that means this right here is going to be a 45-degree angle. 180 is the straight line. To get down to 225, you have to add an additional 45, which means if this is 45 and this is 90, this guy down here has to be 45. Now I've got this triangle, and I can determine the relationships for my trig functions based off of the angle measurements you talked about in geometry. So here we've got a hypotenuse of 1, which is known because we've got a unit circle. And for a 45, 45, 90 triangle, our other two sides are going to be square root of 2 over 2. But since we're in the third quadrant, we know this ordered pair is going to be a negative x and a negative y. So when we move in the negative, or to the left, it's a negative number, and when we move down to get to that ordered pair, it's also negative. So my two lengths there of the sides are square root of 2 over 2, but since we're in the third quadrant, we've got to move in that negative direction. So now that I've got this ordered pair labeled as negative square root of 2 over 2 and negative square root of 2 over 2, I can start doing my x and y analysis to figure out sine, cosine, tangent, and so forth. Now you might wonder, okay, this is on the unit circle, can't I just use that? And for this problem it is. But let's say this angle measurement were not on the unit circle, you would have to use Pythagorean theorem to find your other sides given the fact that the hypotenuse is 1. And then you'd get new ordered pairs that you would use to solve. But for now, this one's on the unit circle, and we'll just use those values. So we know the sine is the y value, which will be negative square root of 2 over 2. Cosine is the x value, negative square root of 2 over 2. Tangent is y divided by x, so negative square root of 2 over 2 divided by negative square root of 2 over 2 is going to end up being a positive 1. The other guys are the reciprocal identities. So for cosecant, it's 1 over sine, so 1 over negative square root of 2 over 2, which simplifies to just square root of 2. Secant is going to be the same situation, going to simplify just to square root of 2, but it's negative since 1 over a negative number is still negative. And then finally, cotangent is x divided by y, which once again is going to be 1. The last concept here then is looking at what do I do if I'm given certain pieces of information, but I don't have enough to draw a reference triangle and solve. And that's where we're going to use our identities that we talked about. Identities are those relationships that we said sine is the same thing as 1 over cosecant, and cosecant is 1 over sine. Cosine is 1 over secant. Secant is 1 over cosine. And all those different relationships back from section 5.2. And if you don't remember what those are, you could pull out page 49. You're going to see the relationships listed here. Sine is being 1 over cosecant, or the y value. Tangent is 1 over cotangent, or sine over cosine. We call those our identities, and we're going to be using those specifically as we solve these problems. So have these identities off to the side if you don't have them memorized yet. So here, given the fact that the cosecant of theta is equal to 3 and the secant of theta is 3 square root of 2 over 4, we want to find sine, cosine, and tangent. So let's start with sine of theta. We know that the sine of theta is the same thing as y, but I don't see any y right there. So I've got to use another relationship that I see on that identity chart. And the relationship that you see there is sine is the same thing as 1 over the cosecant of theta. And I can see right here, I know the cosecant of theta is equal to 3. So I'm going to replace cosecant of theta with a 3. So I end up with the sine of theta being 1/3. Use the same thought process for cosine. The cosine of theta we know is 1 over the secant if you look at that identity chart. And secant of theta we're given right here. 3 times the square root of 2 divided by 4. So really what this is saying is 1 divided by 3 square root of 2 over 4, which is the same thing as 1 times 4 over 3 square root of 2, which is 4 over 3 square root of 2. And then finally we rationalize our denominator, which is going to give me 4 over 6. 4 times the square root of 2 over 6. And then the 4 and the 6 cancels down to 2 square root of 2 over 3. So there's a lot of algebra right there, but the new piece that we're looking at in terms of our trig unit is realizing that cosine is the same thing as 1 over secant, and the fact that I'm given secant right there is going to help me solve that out. The final piece is the tangent of theta. And I know that tangent is the same thing as the sine of theta over the cosine of theta. And I found the sine of theta in step 1. I found the cosine of theta in step 2. So let's just plug in those values. The sine is 1/3. The cosine is 2 square root of 2 over 3. So 1/3 divided by 2 square root of 2 over 3 changes to multiplication, and we flip the second fraction. 3's cancel out, left with 1 over 2 square root of 2. And then finally we rationalize our denominator, and we end up with square root of 2 over 4. If you have not memorized those identities yet from page 49, that would be a great thing to do as we're moving forward in this section.